The word polynomial itself shows the meaning of it. Polynomials, that means poly plus norms. Poly, that is multiple. You know that meaning of poly is multiple. And nomials is something norms. Norms. So we can say that any equation having more than one terms, having multiple terms, should be known as polynomials. As for example, x square plus 1, x plus 1, 2x plus 1, 3x cube plus 2x square plus x plus 2. These are the basic examples of polynomials having multiple terms in each and every equation. Right? This is single variable polynomial. What do I want to convey by saying single variable? Because it is having x only, x as the variable. Not y, not z, not t, not s, right? Only single variable. If it will have y, then y only. If it will have t, then t only. Right? These are the examples of polynomials. If we talk about categories of polynomials, then there will be major three categories. The first one is linear polynomial. Linear polynomial means an equation or a polynomial having maximum power of x is 1. Suppose x plus 1, 2x plus 2. In this polynomials, you can see that maximum power of x is 1. Maximum power of x is 1. So, this is said to be a linear polynomial. Right? Or if we will represent this polynomial on a graph, then it will present or it will give you a line. Right? Now the second category is quadratic polynomial. Quadratic polynomial. Quadratic polynomial is something which has the maximum power of x as 2. As for example, x square plus 2x plus 1 or 2x square plus 3x plus 2. These are the examples of quadratic polynomial. We will represent any polynomial with the help of p of x. Why p? P for polynomial. Polynomial of x. If the variable will be t, then polynomial of t. If the variable will be y, then p of y. Right? Now moving towards the third category of polynomials, which is cubic polynomial. Cubic polynomial is in which maximum power of x will be 3. As for example, 3x cube plus 2x square plus 4x plus 5. This is an example of cubic polynomial. Right, now you got it, what are the categories and why it is being categorized like this: linear, quadratic, cubic. Right? So now we will talk about zeros of polynomials. Zeros of polynomials. You will see the examples in your exercise on the basis of this topic. Zeros. Zeros of polynomial or polynomials. What does the word zero means for polynomial? Let me write an example. P of x equals to x square plus 2x plus 1. So if I will tell you guys that find the zeros of polynomial, then what is the meaning of zeros? Zeros are the value of x. Values of x, which makes p of x 0. Right? Zeros are the values of x which makes the polynomial 0. So if you want to find 0, you will have to consider the polynomial equals to 0 first. Then and then you will solve this to get the value of x. and those values will be known as, will be called zeros of that particular polynomial. Got it? Right? So we can say that if it is a linear one, if it is a linear polynomial, then it will have only one zero, number of zeros. If it is a quadratic equation or quadratic polynomial, then it will have two zeros. If it is cubic equation or cubic polynomial, then it will have three zeros. So you can conclude that the number of zeros is directly connected with the number of maximum power any polynomial has. If we talk about quadratic polynomial, then we know that the maximum power of x in quadratic equation is 2. Maximum power of x in cubic equation is 3. That's why it has three different zeros or three zeros. Right now, after understanding the concept of zeros or the meaning of zeros, let me repeat it again. Zeros are the values of x which makes the polynomial 0. So if we talk about 2x square plus 2x plus 1, we will have to find the values of x for which this equation or this polynomial will become 0. So if you want to find the zeros, you will have to go in reverse. What you will have to do, you will have to accept first p of x equals to 0. Let p of x equals to 0 and then solve that equation to get the value of x. And those values will be the zeros of that polynomial. Right? Now, what is the graphical meaning or graphical interpretation of the zeros for any polynomial? What is the geometrical or graphical interpretation? As we discussed earlier, that zeros are the values of x for which the polynomial becomes 0. Right? So if we talk about the geometrical interpretation, let me tell you that we will denote p of x as y equals to any polynomial here. Suppose let me write x square plus x plus 1. And you know that zeros of this polynomial means this whole polynomial will become 0 for that value. So if we will make a graphical representation of that polynomial, suppose the curve of x square plus x plus 1 will be like this. Suppose, as for an example. So what we can conclude for this, we will have to find for how many times whole the equation or the graph is intersecting x-axis. Why? Because at the point of intersection, our polynomial becomes 0, right? And those are the values of our zeros. Those are the value of the x for which p of x becomes 0, right? So here you can see that 3 times, first, second time and third time. 3 times the curve of our polynomial have intersected the x-axis. That means 3 different times those values made polynomial 0. So these are the zeros of our polynomial from our graph. 3 zeros, right? So this must be a cubic equation rather than quadratic equation, because we just have discussed that if something is having 3 zeros, then it must be a cubic one, right? We just took an example of quadratic one, but if you are saying that the graph of polynomial is intersecting the x-axis 3 times, then it must be an equation of cubic level. Right? Now moving towards another graph. Suppose this is the graph of a linear equation or linear polynomial. Now you can see that only one time it is intersecting the x-axis. We don't have to do anything with the intersection of the curve and the y-axis. You know the reason, right? Here we can see that only one time it is intersecting the x-axis. So we can conclude that in this case number of zeros for our polynomial equals to 1. Right? If the graph is like this, you can see that 1, 2, 3, 4, 5. 5 times it is intersecting the x-axis, so the number of zeros for this polynomial is 5. You are having an exercise to tell the number of zeros from the graph in your chapter 2, right? Suppose the graph is about like this. This is the line of a polynomial. So it is not intersecting x-axis at all. So if it is not intersecting, then we can say that number of zeros for this polynomial cannot be found or 0, right? Because there is no such values of x which makes the polynomial 0, right? So this is all about to know polynomial. Polynomial is an equation having multiple terms of single variable. Then after we have discussed zeros of polynomials. Zeros of polynomials means values of x for which the polynomial becomes 0. Then we have discussed the geometrical interpretation of polynomials 0. The number of times it is intersecting the x-axis will be the number of zeros for that particular polynomial, right? So if you found this video good enough to understand, or if you are having any doubts related to this, then let me know in the comment section. Share this video with your friends so they can learn by being at home only, right? Thank you.